either technical terms or proper nouns and so on, but you still have to make sure that the content is correct. So here's the sort of pipeline. You upload a PDF, then Gemini, which is Google's LLM model, which can handle about 500K words, will analyze it, generate a script, it'll do a neural translation from let's say English to Maithili or whatever. Then it does text-to-speech synthesis and generates the podcast episode. Of course, you don't have to worry about any of these things because you just have to have a few clicks in the cloud. No separate tools are needed. As I already mentioned, it supports a very large variety of documents. Okay, text files with web links and URLs, which can include YouTube video links, and typically it can handle about 5 lakh words at one time. So you could simply upload an astronomy research paper PDF from authors at your institution or elsewhere and just tell it, okay, go make me a podcast. So now we are going to sort of step through the workflow. This was just the step 1. Workflow step 2 would be just configure it, what format you want, what language you want, what length you want, and what should be the focus area. Click on generate audio, wait a few minutes, the audio podcast is ready. But now I'm going to deviate from the standard workflow. So typically you could generate this audio and then start circulating this audio wherever you want. But what I recommend is an alternative workflow which will definitely improve the content of your audio podcast. So what you do now is try to get the script from the audio overview. So you download the audio file, which you can always do in Notebook LM, then re-upload it as a new source, either to the same notebook or to a different notebook. And then just tell Notebook LM, give me a transcript of this chat. Okay? Since the chat is actually AI generated, the audio overview itself is AI generated, it's got AI generated voices with very clear pronunciation, the voice transcription that you will get out is nearly error-free. So you just have to look through it. So you get the transcript, copy and paste the transcript into a document. And then the next step, of course, is to review and refine the transcript. So first thing you should do is verify the scientific accuracy, check for the translation of the various technical terms, ensure the analogies are relatable. Sometimes it gives you analogies which are very Western in nature and so on, or at least not it doesn't follow the idioms of the language, so you make sure the idioms are correct, make changes as necessary. So you basically add or subtract content as needed. Perhaps it's too long, perhaps it's too short, and you do it. So you take your transcript in whichever language you have. Remember, if you give it in, you translate, make a Tamil audio overview, it will give you the output in the Tamil script directly, so you can edit it there. Then the next step in the workflow would be to re-record the transcript in the researcher's voice. Okay? So you take the edited script, preferably have the original researcher record in their own voice for authenticity. An external microphone and an audio editor, there are many. Audacity is something that I like, can be used to capture, edit the high quality audio. And these extra steps in the workflow really personalizes the podcast, avoids subtle errors in science or language, adds to the credibility because it's the researcher themselves who are talking about their work, and enables a direct connection between the researcher and the audience. Okay. You may want to do some post-production using Audacity, maybe add some introductory music, maybe edit and polish the content a little bit, normalize the audio. This could be important because if there are, let's say, 2 people talking, one of their voices may be too low, one of them may be too high, you may have to do something to bring the audio levels to an equivalent level, and of course then you export it as an MP3 or a WAV. You may want to add additional production elements, maybe some music, theme music, or an intro jingle, background ambient sounds, transition effects, and so on. You can also do an outro with credits, so who produced the podcast, who were the researchers, who featured in the podcast and so on. And then you can use the opportunity to advertise the next episode. And then, of course, you should edit and provide episode metadata so that search engines, etc., can find your audio podcast easily. Then you need to sort of publish and distribute the podcast. So the easiest way is to upload to this website, archive.org, and that is really a very nice repository. It's completely free. There are virtually no restrictions on the number of pieces you can upload or how large they can be and so on. You could also create a Spotify account for yourself and put it on Spotify. You can put it on your YouTube channel or you can put it on your website. So to sort of demonstrate this whole thing in action, we made at NCRA a Marathi podcast on the discovery of the Alaknanda galaxy. Here's the Twitter handle. I'll post this whole thing on the Slack so you can go and pick it up from there. So you may also want to think about what distribution channels you would like to use for the distribution. You may want to put it out on social media, the podcast. You may also want to tie up with local radio stations if they're receptive. See, what has begun to happen now is that the staffing at All India Radio has gone down so much that it's become difficult for them to create good content. So you may want to contact them and tell them, look, every week or every once a month we will give you a nice podcast. Will you be able to carry it on your channel? And very likely, we haven't actually explored this, but I think they will be quite receptive. You could post it on school and college networks, so the podcast can be broadcasted. There will be local astronomy clubs, school science teachers, even urban commuters and podcast listeners are going to be your target listeners. You must emphasize that now complex astronomy is now becoming accessible in the mother tongue, okay? And you're actually breaking the language barrier because you don't have to worry about finding writers, finding translators and weeks of work and high costs and so on. Just use Notebook LM, upload the PDF, select the language, click generate, and then a few minutes of work with editing and so on, and using a free tool, and you're done. And this will also, you don't have to do it in one language, you can do it in multiple languages, but that will be hard if you're doing the full re-recording part. But you could do a personalized recording in one language and then just do an automated notebook LM generated output in the other languages. So we can democratize science communication because now these free tools make high quality content available to all, and doing it in a real person's voice makes the local content much more relatable than a machine's voice, although the machine's voice is really good. So here are the key takeaways. Notebook LM transforms research papers into podcasts in many Indian languages. One can modify the transcripts as needed and re-record the conversation. It's free and fast, few hours instead of few weeks. And it makes multilingual science outreach quite easy. But you have to remember the AI may still make mistakes, so please review for accuracy. AI is powerful, but it's not perfect. You can try it for yourself here, and you can start creating this content. Chat to me after the talk for more ideas involving something called Translate Gemma, which is just released about 4 or 5 days ago for language translation. So I think my 17 minutes are done and I'll stop.
It's better to create good content with AI rather than all the AI slop that is around. So questions for you, Vish? Yes. We need a mic.
Thanks, Yogesh, for a great talk. So I just wanted to add that, since I work at the Urdu university, we are actually using this even for our educational material, in the sense that self-learning material also we are doing it in Urdu, I mean, creating it, because again, distance education learners learn better if it's on audio. They can do it, hear it via this. My other question was, what's the difference between the paid version and the unpaid version for this? So are these features for the paid ones?
Yeah, so I've been only using the unpaid version. The free version has all of the features that I described. And as of now, they haven't put any serious restrictions. But if you start doing 10 I don't know, if you start doing 10 podcasts a day or something, whether they will stop you from doing it. But the content itself is freely downloadable. For some reason, they don't give you the transcripts directly. They could have allowed you to just download the transcript because they have it. So you have to go about this roundabout way, download the audios, upload it again and get the transcript. But that takes a minute.
Any other?
Sir, I have a question. Thanks for the beautiful and informative presentation. We are lacking correct, accurate words in several languages, especially in Malayalam. We have no correct translation words.
Yes.
Which source you use for
Yes.
the translation?
So again, my translation experience is limited to Marathi. And as I was remarking yesterday, Marathi we are fortunate because there is a long literature of astronomy in Marathi. And therefore we have all those terms which are there. Now in every state, the state government has provided or has set up a committee to generate a common glossary of scientific terms. I'm sure it will be there in Malayalam. The problem is that glossary, unless it's used, the public is not going to go and read the glossary, right? They just want to be familiar with the word. So you have to use some intermediate techniques. So what I would suggest is you use the glossary. You start providing, putting English words in brackets, start using those words, or perhaps put a glossary at the end of all the scientific terms you have used. So, and ASI has also offered to coordinate, POSC will coordinate the effort of generating a common vocabulary for all astronomy terms in Indian languages. Collate, not coordinate.
Okay, so let's move to the next talk because we are running out of time. And then we can have more chats later.
Yeah.
So the next talk will be by Mopia. She will talk about breaking the chain of misconceptions and the impact of future training workshops. Presentation mode.
Good morning, everyone. So we switch the gears a little bit and now talk about some teacher training programs and the impact it can have on student and teacher understanding of astronomy. So this is a work I did when I was working with Office of Astronomy for Education, which was hosted in Ayuka with Surut. So to begin with, for most students in India, teachers are the For example, understanding the tides or phases of the moon. So most students rely pretty heavily on teachers, how they will explain it, if they would provide some diagram and if they would give some hands-on tools, etc. However, the problem is that teachers in India often do not have any astronomy training at all. That's because that astronomy is not taught in degree colleges or universities. So the last time that teachers themselves had studied astronomy is when they were in school in those classes. So many teachers hold persistent misconceptions of astronomy, and when they teach this in the class, those same kinds of misconceptions can be passed to the next generation of students, and hence the cycle can go on. To break this cycle, you need to go to the source, not the students who are in school right now, but the teachers who can be trained better through targeted teacher training programs. This is well known, of course, and many of us here have actually conducted the programs. But here, I would like to talk to you about some quantitative data, which things like this you can also implement in your programs. So let's see what kind of learning gains we can get if we conduct a good teacher training program. So the two programs that I will talk about here was conducted in 2024. The first one was in Pune in Ayuga here. So this was attended by 46 teachers from Maharashtra and Tamil Nadu. The second one was conducted in Calicut, attended by 30 teachers from local regions. So what we did is, before the survey, before the workshop, we gave them a survey of some questions, some 15 questions, to assess the baseline knowledge of the teachers. Then we conducted the 2-day workshop, and after this we again gave them the same survey to see if there are any changes. So in our sample, we have 51 responses for the pre-survey and 42 for the post-survey. So you should remember that these teachers came with a great interest in learning astronomy. I say this because when we made this proposal of making a workshop, we advertised it, and then the teachers contacted us themselves. And we found that they are very interested in learning this subject. This is in contrast to many TGP workshops which are generally held by, say, government resources, where there is often a top-down approach that teachers are instructed to go somewhere and do the workshops, where the learning gains may not be as effective. So just keep that in mind. And these are all science teachers. They have been all teaching astronomy in school for several years. So in our workshop, just to give you a brief idea before going to the results, so these are some of the topics that we covered: seasons, tides, eclipses, moon phase, life cycle of stars, the basics of astronomy like scales and scales of universe, and pedagogy of how to teach the astronomy concepts better, etc. So we had traditional lectures, hands-on experiments, we had Q&A session specifically focusing on addressing popular misconceptions. So for example, the lesson on moon phases had several of these components. Like this is the image from the NCERT book, but we actually conducted this activity just like it shows here, that you have a sun, a light source, and you are the earth, and then you have a ball, which is basically the moon. So you can just, very simple thing, you can just move the moon and see that the phase of the moon, or the illuminated part of the ball, how it changes with as you move. And so this was a very illuminating exercise for many of the teachers, and this dispelled a bunch of myths. It seemed like, even though this is an activity that has been prescribed in many books already, but a lot of them have never done it. And then we had Q&A sessions for different misconceptions. For example, do we only see one face of the moon? They know that the answer is yes, and because that the moon's rotation and revolution both takes the same time, they know this answer also. But what this actually actually means conceptually was took some time. So this is a figure that we made and we showed. So what it would look like if the moon does rotate around itself and if the moon does not rotate around itself. So things like this we discussed in detail. So the results of our survey. So I will show you a few of the questions that we gave them. So how long does it take for Earth to turn once on its own axis? So 1 day. So the green is the correct answer, and this is for the pre-survey and for the post-survey, and this is the percentage of people who answered this, who chose this option. So 86% people knew it before, 98% knew it after, both good, some lagging ends here. Then we asked how long does it take for the moon to go around the sun? And one option is it never happens, which is also chosen by some people. So you can see that 47% people answers this correctly before the workshop, and it rose to 68%. Arrange these four objects, sun, moon, stars and Neptune, in order of distance. This is answered correctly only by 38% teachers before the survey, rises to 76% afterwards. Sizes from smallest to largest: Jupiter, Moon, Earth and Sun. 82% people know it, and afterwards 92% people answers it well. This is pretty good. Then we chose a question on moon phases. We just gave them these 9 images and told them choose the correct image for different moon phases. So for example, for new moon. So the new moon, this is the correct answer. 83% people knew it before, 95% after, both good. Again, for full moon, again both good. Then we asked them what happens at day 2. What does it look like on day 2 if day 1 is the new moon? So day 2 is, this is the correct answer. Only 26% of teachers can answer this correctly before the workshop, and it rises to about 50% after. For day 8, which is the half moon, 50% and 70%. For day 11, somehow it was about 59% before and 50% later. So apparently they got even more confused. and this was supposed to be the correct answer. So if we look at the options that they chose, basically people were confused between this one, and this one. So what is the shape of the terminator line is what they were confused on. But the remarkable thing is that if you want to look at how many people got all of these questions, all of these phases correct, you will see that in pre-test only 2 people, which is 4%. And in post-survey, it is 11 people, which is 26%. There is learning gain, but still this is not great. Then about tides. So we gave them a scenario. Imagine that the moon suddenly disappears. What happens to the tides? So the correct answer is that there will be smaller tides because of the sun. So this rose from 30% to 45%. But if you see that in the pre-survey, the most common answer is that there will be no tides. That because they think that most people were thinking that moon is the reason for the tides. So if moon is not there, of course no tides. And so this option was decreased. I mean, from 20 to 11 people. So that's something. This one is again, what causes seasons on our planet? This is a very common topic. So the 4 answers that we give here. The first one is distance from sun to earth. This is of course the most popular misconception, and also most teachers chose this before the workshop. So 45% of the population. The actual answer is tilt, because it causes the sunlight to spread differently. This percentage, it rose from only 14% before to after. And so there is a huge learning gain here. And we spent like 2 to 3 hours on the season's lesson with models and with a lot of questions were answered. They had a variety of questions which we didn't even think of to address. So it really showed that even teaching a concept like seasons, like you really have to spend time and a lot of effort to really dispel this very intuitive misconception. Then this was about information. Our solar system contains how many stars? Of course, it's one star, our sun. So 38% to 61% it rose. So I was surprised to see that the most popular answer was several stars before the workshop. So yeah, we had lectures on life cycle of stars and the like scales of the universe, etc. So those things addresses this indirectly. So overall, if we give like 1 marks to each question, out of 15, the pre-survey score was 7. So less than half correct answers were given by a typical teacher. And the post score is 10. So the learning gain, if you measure it in statistical term, is pretty large. So the D estimate is 1, which is a large effect size. This means that there is a substantial conceptual change that happened, even if the program was short, only over 2 days, but it was quite interactive and again hands-on, but importantly that we addressed their misconceptions, their beliefs directly. We asked them, what do you think the answer is for each of the different questions? And then we waited until they gave some answers. And then we tried to explain why this may or may not be the correct answer. So basically meet them where they are and then bring them to the correct explanation, not just give them the correct info right away. So the implications for astronomy education from this whole exercise tells us that the baseline assessment showing there is widespread conceptual difficulty in teachers, even people who are teaching these same astronomy concepts to students for several years. Some of them for 5, 10 or even 20 years. So we really need well-designed teacher training programs which shows that it can produce large conceptual gains in teachers, and so this can propagate to a large number of students later on. So investing in teacher training is one of the most effective ways to build long-term astronomy literacy. Thank you.
Okay, we have more time for questions. Yes, Yogesh first. Just a moment.
This is really depressing in some sense, the pre-survey statistics at least, because we've been talking of improving astronomy or increasing astronomy content in the schools. Now if teachers who have been teaching astronomy for years have such concepts in their heads, it is best that they don't teach anyone, because they would have caused confusion in the minds of so many thousands of students, it's unimaginable. So it's better not to have information than to have wrong information. So what are your thoughts on that?
This is true in some sense. So I'll give you an example. Like when we were doing so we did a similar baseline survey, but with students, and this was nationwide, much larger scale. So for this we had to go to many schools in many different places. So what we found is that in class 8 of Marathi textbooks, the state books, they have a chapter called Life Cycle of lot of it are being taught by life science teachers and teachers who have degree in life sciences. Some of them don't have any science degree at all. They come from geography or something else. So you can imagine that these teachers, when they are teaching these advanced concepts, they have only read it in that textbook. And they read it and then they teach it. So they don't have any better grasp than just reading like 3 pages on this extremely complex topic on which like whole graduate courses can be taught. So you really need to give teacher much more detailed training if we want to implement advanced topics.
Exactly, this is what I wanted to ask. Whether teachers teaching astronomy or and astronomy, we are talking as astronomy teachers, whether all the teachers, the sample you took, were astronomy teachers or like any other background teachers. So you have
We asked, so when we got applications from many teachers, we asked them if they teaches astronomy. And all of the people here, they do teach astronomy. But not all of them have physics degrees. Most of them here have science degrees though. And many of them have masters, so in chemistry or in bio. Some, there were physics, a couple of mathematics people were there.
Just to clarify, so when you say they teach astronomy, it means they are teaching subjects in which there were astronomy
Correct, yes.
topics rather than being direct astronomy.
Yes.
Maybe that was one of the confusions.
Thank you, ma'am. I'm Shiv Shankar from Kolkata. So I just wanted to know that if you have considered, after, I think so it was a 2-day training, right, for the teachers. So after this training is done, let's say after some months, have you considered getting some feedback from them like this questions, like when they're not connected to any kind of such training, if that misconceptions come back to them or like they have forgotten everything. So is that the case?
This is a very good question. We actually did not do this, but we have plans that in future when there is a TTP, there really needs to be a long-term engagement. So we kept contact with them for several months after this. They were pretty active in our WhatsApp channel. But after that, we did not have time or resources to do that. But yeah, this is one of the pathways.
Sure. Thank you.
Yes, good morning, ma'am. Actually, the International Astronomy Unit, otherwise the unit, can recommend all the state government what should be teaching, what should be taught in the school, and what should be added in the curriculum. Because in 6th and 7th standard of Tamil Nadu textbook, it included astronomy as the first lesson. Later on, from 8th to 9th, the lesson was removed. So nothing is included in that lesson. So that students are not aware of the astronomy when they are entering into the 9th standard or 10th standard. They are focusing only on the content, what they want to write in the public examination. So they are not even touching astronomy in the 11th and 12th standard, also in science and mathematical stream. So that to teach astronomy in the school level, we should have a prescribed format, and we should recommend some activities for the classes also. Thank you.
This is a great point that there should be like a central repository of ideas, and yes, the IAU has actually done it. So there is a resource called Big Ideas of Astronomy. So this was written by astronomers from all around the world, and this was exactly the purpose that we give teachers a framework of all the ideas that a school-leaving child should know. By the time they are 18, they should know. So this is a document that is freely available, and you can talk to me later and we can chat more.
I just want to add one point. We did this all through the year for the same set of teachers, and I wouldn't give up till the later half becomes 99%. And they understood that impact very well, and therefore they kept coming back. Although it was repetition, still they understood it very correctly, and fortunately we had the planetary projector to show them the actual events, and so they were able to do that. Unless you put in this kind of an effort, you will never be able to make it to 99%. There will always be something you have to compromise.
Right.
Okay, thank you.
Thank you.
Let's move on to the next talk. Miss Nitya, Imagining Astronomy to the scratch.
Yeah. Good morning, everyone. Thank you again for letting us be a part of this wonderful conference. And being on day 3, we have been able to absorb a lot of, different kinds of space education that is going on around the country. So I hope that, we can also present something that ties in with a lot of different people. My name is Meela Mitra, and with me is part of this presentation is on this product is Gautam Agawari. We are from STEM and Space, which is a space education company, and we have been doing the model that many of you are doing, except we are doing it for urban schools. So it's a different set of problems. It's a different set of, the level of activities, the level of conduction, and it's financially very expensive. So we have a different set of problems, and based on our experience and what we feel, there has to be a move. So we are trying to redefine the word education as engagement. Okay, so as we go forward, I'll try to explain why we feel there needs to be more engagement and not just education. Okay, so just to give a context and background, of course, everybody in this room is aware of this context that, when Chandrayaan 3 landed successfully, there was so much noise, there were people sharing mithai, people getting dholak on the streets. Where did that excitement go to? Does it translate to students who are actually interested in getting into the space industry, in finding out more, being a part of it? I mean, Chandrayaan 3 was more popular than cricket matches, but now that it is waning. It has caught hold of some people, but has it caught hold of a large group of kids? So the question is how to link this moment of inspiration to build a scientific habit. Similarly, can we train these kids to, not only just attend a workshop or attend an astronomy class, which they enjoy, but can they get up and think every day, I'm going to log in somewhere, I'm going to read up something of astronomy or space news, or how did even this Chandrayaan land? How did it go so far? So we are proposing that we need to make space a daily habit for kids. So that's why we're calling it engagement. How do they do that? Of course, there's YouTube, there's Instagram, and they have different ways to access news and fun things, fun games. But we want to think of a way that we provide tools for this engagement to happen. Okay, so again, we have a space momentum. Of course, we all know the space industry is positioned to grow rapidly. We will need people, we will need kids who are trained and have the skills. And, there's a growing middle class who are looking for meaningful engagement. But we don't have all the sessions we talked about today in astronomy education. Do we have a way to scale it? Do we have a way to get it out to everywhere in the country? And also make it a pathway where students will access regularly. So, and of course, we are working mostly from Delhi and in Bangalore and in Hyderabad. But can we scale this so it goes everywhere and not just the heartland? So based on these concepts of how do we scale it, how do we provide ways for teachers who are not trained to take this forward, and how do we make it a daily habit, that is what our engagement is based on. And to give a little more context, NASA, if you go to the West, it's not just astronomy education, it's everywhere. It's in t-shirts. You can visit space centers and buy merchandise. So there's so many movies on space, there's so many games on space. So it's in your daily life, it's part of the culture. And as a group, it would be great if we could also make it part of the culture. So the present approach is traditional science, which all of us agreed that, we need. Of course, we are working with the second model, all of us, which is astronomy in education. And that's astronomy clubs and space labs now. But like I said, the problem of that is it is exciting to kids, but some of the space club sessions are still formula intensive, they are technical, and they are expensive in urban schools especially. There's a lack of resources. Like Priya also said, where do you get so many astronomy trained teachers to take it around? And also, how do you scale it to reach everybody? So based on these, we have come up with a proposed solution, and we call this fun name, approachable for kids. So we have 3 rungs: Spacetopia for kids, Spacetopia for educators, and we have products and publishing that tie in to both of these. Okay, so I'm going to tell you a little bit about each. Spacetopia for kids is a web-based platform. It's membership-based. The basic membership is for free, and then there are more premium memberships. And what do we have here? We have really fun stuff. So here what we have done for kids is we've downgraded the level. It's not so technical, it's more fun, and we have introduced things like e-books and comics, bite-sized videos. I know some of my colleagues talked about 8-minute videos. We have it 1 minute, and it only asks a question. It's not like, what is a black hole? Or why do you see one side of the moon? Maybe you can find that on YouTube. We take expert questions like, what happens if the moon goes away? So we've answered questions like that, which are answers to questions which you may not find so easily on YouTube. And we also have activities, and we don't want just kids to log in. We don't know what they're doing. So we do have expert sessions frequently, webinars. We train them in do-it-yourself. We do Ask an Astronomer. So all these are live sessions that we guide them. But meanwhile, they can play this cosmic wheel, and they can come and look at the ebooks and comics, and so on. And so I have a couple more slides of this. So when you go in, we update what astronomy news. We also have things you can play with, game-based. We also have comics. And here I want to share that we are, in fact, creating our own comics as well as using some NASA comics. So I'll show you briefly. So mostly we create them online, but here are some that we have tied up with publishers. So here's a book on auroras, and like I said, we make the books very fun. So they're character-based, but we have we have squares on top that tell you what the concept is, like for auroras, magnetic field, or charged particles. We also have a book on space careers. Yeah, sorry. We have a book on space careers that everybody knows that there are careers like astronomers and astronauts. Do they know we've introduced new careers like space lawyers, space debris engineers, space tourism, things that are going to come up in the future. Okay, so yeah, this has moved on without me. So yes, so we are reimagining how to make space a daily habit, and this I've already gone through. Okay, so let me go back. So we have Spacetopia for kids, for teachers, and the publishing. Okay, again I was talking about Spacetopia for kids. So I go forward, and this is comics, some of which we've designed ourselves, and they're like flip books. So as you open it, you can look at them. And I'll just give you an example of Aditya L1 mission. We were asked to do it with somebody, and Aditya L1 is hard to explain to kids, but we make it through stories. So Aditya was a character who was going out to conquer the world, and he had the payloads as his friends. Okay, so also we have Spacetopia educators, and many of you might be interested in this concept because we try to make it a plug and play. We've already given sessions in not bite-sized, proper session videos, but you can play it in modules. And so we call it plug and play curriculum. It's curated to go from basic astronomy to more advanced to space applications. And you can use STEM challenges. So every lesson has a video to play, it has STEM challenges, it has activities, and it also has expert support because you become a part of this system. Okay, so who can use this? Schools, aspiring individuals who want to get into astronomy education, activity centers, and again we have a user-friendly interface, and we have, again, some of you brought up that how to align it with NEP because they're taking out astronomy sessions, but again we made the effort to tie it into gravity or light or things like that tie into basic physics or astronomy, whatever there is. And we have curriculum clarity, what is the lesson objective, and what will they learn at the end, what is the roadmap. So again, just a brief glimpses, these are the kind of sessions. So if you go in, you'll see for junior students, we have it based on stories and characters because that helps them remember. It doesn't have to be formula based. And we have some characters that go through all the stories. And we have, for seniors, we have, starting with basic astronomy, you all know these topics, know your night sky, spectroscopy, galaxy sorting, but we also go on to applications like topographical maps and astrobiology. So we have topics like that. Okay, so once you go into the session, this is what you get. You get a session breakup of 3 videos you can play. You get the learning outcomes. We get resource and teacher's guide, and you can upload photos. So this we feel will actually help grow teacherpreneurs who can take forward their own teaching sessions. If you're a science teacher, then equipped with this, you might be able to take these forward. Okay, so Spacetopia products. This is the third prong of the three-way Spacetopia. We have comics with narratives. We have, like I said, we make them into stories, so you remember the context of the stories. We have pop-up books. We have, we have activities also. I'll just quickly hold up a couple of activities. Okay, so for juniors, we have all the way from very fun activities. Sorry, this. Okay. So, okay, I'll go back to that. For juniors, for example, we have a very fun activity which is binary bracelet. So we help them understand how data from space comes in numbers, or zeros and ones, and through that they make their own name into a binary and make a bracelet of 2 colors that represent 0 and 1. And then for seniors, of course, we have planisphere, sundial, but we also have things like topography that we teach. Okay, so let me quickly go forward as I'm talking. So we have taken these things forward, and we feel that there is this will help create, this will help astronomy education be taken around more widely, and we also hope that these will increase entrepreneurs who can be teachers, individuals, and we are doing all these activities that can be separate or they can be part of this session. And so again, we have a junior model which is dealing with characters, aims, storytelling, and we've simplified it so it's very fun, because why it works, kids don't remember formulas, but they will remember the story. Like the example I gave, Aditya L1, if you ask a kid, what did it do, what was L1, but here they might remember because there was an adventure story and Aditya was bravely going out into the world to face the sun. Okay, so we hope that games and books will help students remember and not make them feel that, oh, it's too technical, it's not for me. And for each grade, of course, we have a more advanced layer. And anyway, for seniors and middle schools, we make it more interactive and investigative. And each session has an activity. So with this platform, we also did outreach. Because now we have a ready group of people who join in. So we did National Science Day, National Space Day, 50th anniversary of Aryabhatta, anniversary of ISRO, World Space Week. So the good thing is we have audience that log in, we are connected to them, and we can hold special sessions like quizzes, debates, or webinars for them using this platform itself. And I'd like to share that we were lucky enough to be given a grant by IAU and with OAE Astronomy Education, OAE, IAU and OAE India, and we did this workshop at Aries Observatory, and Dr. Virendra sir is also here. He was one of the experts, and so are experts from HPCSC who are also here. And so we did an immersive experience where we showcased this platform, how teachers can use it, just stand here, play it, and conduct sessions. And additionally, we had observatory tours. We had expert conducted sessions. Okay, so what next? We have already established the Space Kids platform, Spacetopia Kids, and we have a participation, and we still have to manage it. We have to bring kids in, they go out. How do we bring them in regularly? How do we increase their interest? And Spacetopia educators, we have done this pilot run. We want to do it with a few more schools and then expand it outwards to more schools. So I have
Welcome to Spacetopia for Kids, a platform designed specifically for parents and children. Spacetopia is a mission driven by academicians, researchers, and educators with one belief. Every curious child deserves access to space. The child's journey begins the moment you log in to Spacetopia and enter the dashboard, where a universe of possibilities opens up through our carefully designed menu. Explore our space comics, watch immersive videos, and learn at your own pace through certificate courses.
So with that, I've cut this short. I can talk to anyone more about it. With that, I would like to close saying that we are thinking of an objective of how to make space education and space engagement more accessible, scale it out so it goes to everyone, and make it fun so you don't always think of it as just very technical. So that is our goal, and with that, I would like to thank the organizers again for inviting us today, and I hope we can tie in with a lot of educators who presented their space education topics, and thank you again.
Excellent, thank you. So the workshop that was conducted by STEM and Space at ARIES, that is part of this IAU OAE program called Teacher Training Program, so they do fund workshops. Next time there is a call, we'll try to circulate it over the workshop WhatsApp group, so that you guys also can team up with some of the National Astronomy Education Coordinators in order to apply for these workshops.
Thank you.
Okay, let's take some questions. Yes, here.
Hello ma'am, that was a nice talk. I have a question to you as well as the previous speakers, that this is a very good example of non-formal learning where you are giving the courses online to students directly, and we find there is a gap in the formal education where teachers are also having problems of learning because in their education they have not learned astronomy. Wherein I have presented a poster where I mentioned that when I opened the course of hands-on activity in astronomy and space science, instead of 45 students registered, I have to increase the number of registration. That means there's a gap somewhere that students are interested to learn. There are teachers who are not trained, but we are doing informal or non-formal learning more accessible to the astronomy rather than adding astronomy in formal education to students in their curriculum as well as to the graduate and postgraduate and probably the PhD levels. We have hardcore researchers, but we don't have anyone specifically learned who can teach astronomy to students. So it's question for an open discussion. How can we go ahead about it to the officials or the ASI members here? Thank you.
So I think this might be one of the topics in our open list. But yeah, I think we all have the question of how it becomes more part of the curriculum. But what we have done for it, I can only speak for us, is we have tried to tie it in, and when we show for each grade, we show some NEP alignment, and we try to convince schools that it is connected to you because there's a topic on light or earth. We tie in layers of the atmosphere, how rockets fly. So we have tied in some earth sciences, atmospheric science, climate. We have these topics, so we try to show the teachers at schools that it is aligned at least in some way, so that schools take it in more into part of their formal curriculum.
Hello ma'am, interesting slides. So comics is a great start for the kids, but how do you actually, because it is taken as an activity for the kids, how do you actually convince them to pursue as a career? So what is like...
How do we actually pursue?
Okay. How to take it more seriously?
So that's, there is obviously a gap, we are actually targeting younger students. So I think most of us have found that students beyond 10th are hard for informal astronomy teachers to get to. So most of us target till 9. And we specifically are targeting even 2nd, 3rd, 4th because we want them to get an idea of space and enjoying space. So careers, how to tie it in, that's a bigger question. But we try to make them aware of the missions that are coming up, and also how the industry is growing. Like we interview people from different startups, and so maybe space, and we of course have a book on space careers, how to go into each of these careers. And when I give this talk, I tell people who's interested in gardening, who's interested in law, and many kids raise their hand, and you can tell them you can be a space lawyer, you can be a space doctor. So we are trying to introduce it to kids from their angle, and maybe that will help them go into these kind of careers. Thank you, everyone. Thank you.
One more thing, Mopia, you can also share the resource link, because the TTP program that we ran at Ayutthaya, we did maintain the resources as well, so they can be put it in the WhatsApp group. Okay, thanks to all the speakers of the morning session for wonderful talks. Thank you. There's one announcement from the LSE, so Samir.
Good morning. Good morning. What a sleepy good morning. Good morning. Good morning. And yes, we'll give you tea. Don't worry. Latin. I know. That's all I know. That's all Latin I know. We'll give you tea, and after the tea break, we'll request all the backbenchers to please come in front, because the speaker feels very lonely. So we've had various complaints that he's talking to